Hi, in this short video we're going to clean up some of the preliminaries that we started on Wednesday and leave ourselves in good shape to begin talking about descriptive statistics, including frequency tables, on Friday. Last time we had a conversation about what makes science science, that is, science as a method or approach. We talked about systematic empiricism, which means not just looking at how the world works, but doing so in a controlled and organized fashion. We talked about public knowledge, which means that we share what we know and why we think what we think. And we talked about solvable problems, phrasing things in essence in a way where data can tell us the answer, and if we're wrong, the data can tell us that too. We then moved on to talk about numbers and realizing that a 2 is not always a 2. Using a 2 to mean that somebody is from Iowa is very different than using a 2 to represent how many apples you have. So we talked about nominal scales, ordinal scales, interval scales, and ratio scales. And I encourage you to keep thinking about measurement as we move through the course. Another thing that comes up in statistics is the distinction between a population and a sample. And a population is an aggregation or an aggregate of all the cases to which one wishes to generalize. It can involve the past, the present, and the future. So for example, if you're coming up with a drug to treat Alzheimer's disease, you might hope that it not only would work for people that currently have Alzheimer's, but also for people in the future who are going to get the disease. So populations can be defined in an infinite number of ways. So you could decide that the population you're interested in is all current Colgate students. A sample is any subset of a population. Our class, Psychology 309, is a sample of the Colgate population. It's not a random sample, it's not a representative sample, but it is a sample. So sample simply means any subset of a population. How we sample really matters. It goes beyond this course to really talk about all the ways that people use to sample. But the goal of sampling techniques is generally to try to find a representative sample. And this is tough because often we're doing this in a situation where we don't really know what the population looks like, for if we did, we wouldn't need to sample from it. A common way to do sampling in the behavioral sciences is using a random sample, but you can imagine there's other approaches. The world of statistics is often divided early on into two arenas. The first is descriptive, and descriptive statistics are used to describe a sample or a population. Mean, median, mode, all measures of central tendency and variability can be used descriptively for both samples or populations. When we only have information from a sample or samples and we want to draw inferences about what is going on at the population level, we're using inferential statistics. So inferential statistics are used to take a sample or samples and draw inferences about how a population or populations look. Lastly, and we'll be done soon, your book in chapter 1 uses summation notation. And as you can see in this top left example, sigma, capital Greek letter sigma, is used to indicate summation. A lowercase I is often used as an index, a variable itself that can take different values. In this case, this is telling us that we're going to let I go from 1 to the capital letter N, which is often a constant used to represent how many values there are in a condition or a data set. And so what this is telling us is that we're going to increment I from 1 through all the values between 1 and N, and wherever there's a subscripted variable with an I, we're going to use all those values in turn. So sigma x subscripted I is saying add together all of the x values going from 1 to n. So you would do x sub 1 plus x sub 2 dot 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 up to x sub n. We use this so often that it's shorthand to just write sigma x or sigma y or sigma z. And we all know that if it's not otherwise indicated, this is telling us to add up all of the variables in this area. Now your book stops there. I mean, obviously it has you work through things like sigma x times y. It encourages you to see the difference between sigma x, that whole package squared, versus sigma of x squared. But what it doesn't do for us, and we need in this class, is for you to get a sense of nested summation notation. And with nested summation notation, you work from the inside out. So this, for now, you can think of as working just like it did in the first case. We're going to let I go from 1 to n. And with nested summation notation, we first start on the left by setting our index there to whatever it tells us, but usually it's 1. And that's held constant as we work through all of this. And then we move out, increment that 1, and keep going. So in this case, this is saying take x sub I and multiply it times x sub j, and do that for all of the x's for each individual y, starting with y sub 1. So you would go x1, y1, and then this would increment, x2, y1, increment again, xn, y1, and then once you get to the I being equal to n, it shifts back down to 1, the j increments, and you go again. x1, y2, x2, y2, xn, y2, increment the j, x1, y3, etc. Here we're letting k represent how many values of y there are. This matters to us because we're going to be just a few weeks away from looking at things like this, and we just are going to need to very quickly get this summation notation down. This is telling us the sum of squares within involves adding things across 3 different indices. And in this particular instance, it's going to take each individual x within condition j and condition k of 2 different variables, subtract them from the mean of a certain condition, and square that difference. This is going to be an interesting, complicated idea. I'm not expecting you to understand that now. But to start getting your mind around that, this is just going to say set j to 1, k to 1, increment the i's, and then set j to 1, k to 2, increment the i's, etc. And then once we got k going from 1 to b, it would come back to 1 and the j would go to 2. So this keeps scaling, although this is about as ugly as we're going to see it in Psych 309 this semester. So please make sure you're comfortable with summation notation and rounding. Find me if you have questions about any of these things. Some of us pick this up quickly because we've been exposed to it before, but for those of us for which it's new, it's reasonable to spend some time working on it and to have questions. Find me. Also, and I know I mentioned it before, but think of this as second language learning. This summation notation is representing ideas in addition to telling you which calculations to perform, and the sooner you get into a position where you're comfortable with that, the better. So, as a quick review, most of us are in this course because we're majoring in psychology or neuroscience, and somebody told us to take it. They told us that because statistics plays an enormous role in the scientific method. It's a valuable tool to possess. We've talked about measurement systems and how understanding measurement is non-trivial but important, and we will continue to talk about it throughout the term. And we've made lots of distinctions so far. We've talked about quantitative versus qualitative variables, independent versus dependent variables, discrete versus continuous variables, nominal, ordinal, interval, and ratio variables. We've talked about populations and taking a subset of a population called the sample. We've talked about inferential as compared to descriptive statistics. As we move forward on Friday, we're going to talk about frequency tables, including frequency and relative frequency, which can be used for all variables, nominal, ordinal, interval, and ratio, and cumulative frequency and cumulative relative frequency, which can only be used for ordinal, interval, and ratio variables. Look forward to seeing you Friday. Hope all's well. Thanks for watching.